All right. So again, on the exam, I'm going to ask you how a macro is, I'm going to have you answer how a macro is, digested. Okay. I could ask you the whole shoot match, or again, happening in a specific location. Now, if I ask on the exam, if I ask for, let's just say we're talking about lipids, lipid digestion in the small intestine, and you start talking about the mouth, and you start talking about the stomach, did you answer the question? Well, you're going to be like, well, I talked about small intestine too. Yes, you did. But did I ask for the mouth? Did I ask for the stomach? No, I asked for something very specific. Okay. So on the exam, read the question. If I ask for how are lipids digested? Mouth, stomach, you can go the whole shit. Mouth, peristalsis through the esophagus, stomach, what happens there, what happens in the small intestine, what happens in the large intestine. You could talk about it all. Okay. But really, what did I say? Mouth, stomach, small intestine. Those are the three major areas. If I ask that, describe lipid digestion, that's what you're going into. If I ask for lipid digestion only within, or describe lipid digestion within the small intestine, only talk about what's happening in the small intestine. Okay. I know it's subtle, and unless you totally messed up what happened in the mouth and what happened in the stomach, I would take off more. But if you put those down and I'm only asking for small intestine, I will take a point or two away. It just depends on how upset I get at my kids that day when I grade your test. Okay. Why you're like, man, why gotta be such a DH? Okay. Because a lady that I know applied for a job. How do I know? Because I was a reference. Okay. She did not get the job because she did not answer the question, because she called them and asked. And on her application, she did not answer the specific question. She went diatribe. She wrote everything out. Okay. If I ask for everything, I will. You will get that. Okay. Lipid digestion. Discuss lipid digestion. 9 points. Discuss lipid digestion in the small intestine is asking for something very specific. And so that's what I'm looking for. So just subtle differences between how I ask things. Okay. So let's get into lipid digestion here. All right. Again, what are going to be the enzymes here? These are going to be lipases. Again, just a general name, right? We have salivary amylase. Salivary lipase. Fix that. Holy smokes. Okay. Lingual lipase is what's going to be secreted in the mouth. Okay. When we talked about this in chapter 4 in the digestive system notes, we talked about lingual lipase being secreted in the mouth. It's part of the salivary mix, right? But remember, it's not activated until it hits that acid content of the stomach. Okay? So if you wanted to tell me about what's happening in the mouth, go ahead. What would you say? There's mechanical digestion occurring because of the teeth and the tongue, keeping the food from getting away from the teeth, mashing it down mechanically, mixing it with saliva. Lipids. What's in saliva? Lingual lipase. And even though it's mixing with it, nothing is happening. Why? Because it's inactive. It needs an acidic environment. Okay. Then you can talk about in the stomach, that lingual lipase becomes active, hits the hydrochloric acid, and that, boom, I start getting a little bit of lipid breakdown. Okay. primary site is going to be the small intestine. Open up that pyloric sphincter and chyme enters into the intestines, small intestine. So as that fatty chyme is entering into the small intestine, the intestinal cells there are two major secretions. Secretin and cholecystokinin. We saw these in chapter 4, I think. Secretin acts on the pancreas to secrete a bicarbonate. What's bicarbonate? Buffer, right? Again, this is acidic material. So I have that buffer, right? But secretin also stimulates the production of bile. And who does that? The liver. Okay? Remember, the gallbladder just stores it. Cholecystokinin is what causes that gallbladder to start becoming pulsable and gets it to squeeze some out. That bile enters into the duodenum and it'll start to do its duty. Cholecystokinin, as you can kind of see, also stimulates the pancreas to release their digestive enzymes. Which one do we care about right now? Something with a lipase on it. Pancreatic lipase. Pancreatic lipase comes from the pancreas. Lingual lipase comes from the tongue. So just by this sheer slide, sorry, what slide is it? Slide 38? So just from this one stupid little slide, we are basically saying that the bulk majority of the action is happening here in the small intestine. Not much happens in the mouth. Mechanical, lingual lipase gets secreted, but it doesn't do anything. In the stomach, okay, now lingual lipase starts to become activated. And we start to get a little bit of initiation in the breakdown of this lipid molecule. But the vast majority of action, the vast majority, excuse me, of digestion is going to occur within that small intestine. As soon as this fatty chyme enters into the duodenum, secretin, cholecystokinin get dumped in. Okay, the intestinal cells secrete it. Stimulates the pancreas to secrete bicarbonate, a buffer. Stimulates the liver to produce production of bile. The liver doesn't produce it all the dang time. Cholecystokinin gets secreted. Stimulates the gallbladder to release the bile. Bile enters into the small intestines, into that duodenum. It also stimulates the pancreas to secrete pancreatic lipases, which is going to help to further this breakdown to occur. What does bile do? Well, this is what bile does. It aids. It's an emulsifier. Okay? Bile is that lectin that we just talked about. Okay? It helps us to keep the fat that we are breaking down into small bits, into small particles. This allows me to get this into the cell. But why? How does it do that? Again, by increasing surface area. That's all it does. Okay? Helps to make this huge fat blob, globule, however you want to say it, into smaller globules. And that's what you're seeing right here. Right? Here's the bile getting dumped out of the gallbladder. Okay? And it takes a large fat droplet and helps to break it up into smaller bits. Okay? And that's what an emulsifier does. When we say bile emulsifies fats, it helps to make it into smaller bits. That's it. That's what bile does. Bile helps to facilitate the action of the enzymes. Pancreatic lipase is going to be that enzyme. So I need bile. to effectively allow pancreatic lipase to do what it do. What does pancreatic lipase do? It's a digestive enzyme. What in the world does that mean? This is the enzyme that's cutting those fatty acid chains. Takes a triglyceride and makes it into a monoglyceride. Bile gets released first. Bile is released from the gallbladder. If you don't have it, then obviously it's coming from the liver. But we're just talking about normal situations here. Okay. So when bile gets released, it helps to make that large globule into smaller globules, facilitating the action for the enzymes. Pancreatic lipase. Greater surface area, greater effect of pancreatic lipase. What can pancreatic lipase do with all that surface area? It can now cut up those fatty acid chains, and it removes two. And the fatty acid chain can be absorbed. So can glycerol as well. That's these fatty acid chains that can be readily absorbed into the cell. And here you can kind of see that. Here's my here's my bile being secreted by the gallbladder. It's acting on the large fat droplet, makes them into smaller. All it does is increase the surface area. Here's the surface area. If I have one big fat droplet or 10 smaller fat droplets, 10 is more surface area to it, right? And that's what bile is doing. More surface area for pancreatic lipase to act on the triglyceride within it. What does it do? Well, it breaks a couple of fatty acid chains off. Can I do that last one? There's some intestinal lipases as well. Okay. There's some intestinal lipases as well to help facilitate the further breakdown of it. But I mean, it's okay. What we have here, that's sufficient enough. Okay. Bile, pancreatic lipase, secrete, cholecystokinin before them. All of this happening in the small intestine. So can you see there's a lot of stuff going on in the small intestine? Now that you've taken a test, can you see where I might probably just ask lipid digestion only in the small intestine? I hope that's what you see. Now you're starting to think like me. Now you're awesome. All right. So I've broken this thing down. Okay, I've broken this fat down into our basic component parts, free fatty acids and glycerol. Now what? Now I got to absorb it. Okay. And again, the vast majority of this is going to happen within that duodenum and the jejunum. All right. There's a little bit that occurs within the ileum. So if you want to just say small intestine, fist bump. Awesome. Okay. Depending upon what you are, and when I mean what you are, what type of length of a chain you are, depends on where you go, how you're absorbed into the system. If you are very 2 to 4, remember those monikers of short to medium to long? If you're something really short, you easily get absorbed into the intestinal cell, okay, in the villi of the intestinal cell. And you can easily get into the capillaries, the blood vessels, the bloodstream, okay? So short chain fatty acids get into the blood really easily, very quickly. Medium chain fatty acids, they're not as fast as short, but they can still enter into this capillary network, into this blood vessel network. Okay, this is the bloodstream. Long chain fatty acids, they require a vast number of steps. They require additional steps, all right? But once I've broken down this triglyceride, okay, and I have short chain fatty acids associated with it, or medium chain fatty acids associated with it, absorb them into the cell, get them into the blood, and off we go throughout the circulatory system. When it comes to a long chain fatty acid, now I need help. Now I need help because I need to get them into this other system called the lymphatic system. How do we absorb long chain fatty acids? Well, here's a wonderful picture here showing this nonsense. Okay. It's actually a continuation from this. Okay. I've broken it down and now I'm at that absorptive level. Okay. I'm at the intestinal cell. Here you kind of see the pancreatic enzymes are coming in there. There's my longer chain fatty acids. Again, I've stepped off. Okay. But again, everything else is here too. The glycerol backbone, the cholesterol that naturally exists within that food, all of it's sitting here. Any fat soluble vitamins, all of that's here. Okay. And again, it's all these enzymes, all these lipases that have been acting on it, breaking it down into those smaller bits. There we go. Okay, there's my long chain fatty acids, there's my cholesterol, and there's my monoglyceride. These I absorb. Okay. But before these things kind of come on into a cell, I package them all up first. So in other words, my digestive system has done all this work to break these individual components down. But to get them into this thing, I need to congeal them all together. And I congeal them as a micelle. That's what it's referred to as. Okay, it's cholesterol, it's phospholipids, it's long chain fatty acids. It's all the fat soluble stuff except short chain and medium chain fatty acids. Okay. I put them in this micelle structure. Okay, and it's just a small little structure right there. Okay, and we bring that in. We bring that in. As soon as I've brought in that micelle, we unpack it. We unpack it, and then we have my monoglyceride, I have my long fatty acid chains, and I got cholesterol. Anything else there too? Yeah, there's a phospholipid. Okay, that was cellular structure of the meat that I ate. And I assume there was protein profile in there as well, as this is meat. So there we go. So the protein got absorbed in as well. Another mechanism. Talk about that next week. Okay. All of these things get unpacked. Okay, so as soon as that micelle enters, we unpack it. There they all are. They all existed out here, but I had to put them together to get them in, and then I unpack the suckers. What the hell? A lot of work just to have everything congeal back together. Yes. Once all these individual parts here, triglyceride, this dude here, right there, got reattached. There's my triglyceride. There's my cholesterol. There's my phospholipid, protein. Inside the intestinal cell, I package all of these things together. And I form this structure right here, the chylomicron. As you can see from the picture here, that enters into this thing called a lacteal. I'm going to write up here, this is the lymphatic system, everybody. Lymphatic, lymphatic system. All right. This will ultimately get into the blood. How? We'll finish that conversation next week. All right, so just to review real quick, okay, we have our fat that we eat. It gets into the small intestine. That large droplet of fat Again, lingual lipase in the stomach helps to make these large fat droplets possible. As soon as this enters into the duodenum, cholecystokinin, right? Gets secreted by the intestinal cells, causes the gallbladder to secrete that bile, breaks it down into smaller fats, emulsified lipids. Okay? This increases the surface area for the pancreatic lipase, again, okay, from cholecystokinin, to do what it do, help to break up that triglyceride. Breaks it down to free fatty acid chains and a monoglyceride. There are some other enzymatic activity as well from the intestinal cells. They'll get in the game a little bit, and they'll help to further this breakdown as well. Right? But these are the major things that we've got. If these are small chain and medium chain fatty acids, easily absorbed in, put into the bloodstream, and ba-boom, off they go. If they're long chain fatty acids, they don't come in absorbed very easily. Okay? They can't get into the bloodstream very easily. They're too big. Chain. Same thing goes for cholesterol and that monoglyceride. Right? We package these up as it gets close to the absorptive cell surface, as it gets close to the intestinal cell. We package all of this up in what's referred to as a micelle. Okay? And you can kind of see that right here. Right? When we look at a micelle, it has phospholipids. Okay? I'm sorry, I am not a very good drawer. Okay? And inside, my long chain fatty acids, my monoglycerides, my cholesterol. Okay, package it all up. Now I can get this phospholipid to fuse the phospholipid bilayer here, and bada boom, bada bing, I can absorb all those components. It gets inside the intestinal cell. Okay, the micelle basically unpackages itself. All the parts and pieces get released inside the intestinal cell, and I reconstitute my triglyceride. Cholesterol is still there, phospholipid is still there. Anything else that I've absorbed is in here as well, like carbohydrates are in here. Proteins in here, but I don't care about carbohydrates. Inside the intestinal cell, I package all of these components up: triglycerides, cholesterol, phospholipids, protein. I package all of that up and form this structure called the chylomicron. Chylomicron's going to enter into that thing called the lacteal, the lymphatic system. Under normal conditions, most everything gets reabsorbed. Okay, most everything gets absorbed, I guess I should say. Nearly all your triglycerides, nearly all your phospholipids, nearly all of that gets absorbed. Only about 50% of cholesterol is absorbed. It's unique. So if you have sterols, you can absorb even less of that. Okay? Which again, not a bad thing. The only thing that would interfere with that if you have an issue with fat malabsorption, okay, and there are certain conditions that inhibit the body's ability to absorb fats properly. Okay? If you have impaired fat absorption, generally that's going to go hand in hand with a fat-soluble vitamin deficiency. So there are a few of them, and I honestly don't want to get into them. Some common symptoms, because how would you know? Really, it's diarrhea. Technically, the fancy name is called steatorrhea. Steatorrhea is just when you have an abnormal amount of fat in your feces. If you look after you've had a bowel movement, fat in the feces themselves, they won't look brown anymore. They'll have inner spurts of white. Back in the day when they created olein is a chemical that is kind of a fat, and it mimics fat, but the body doesn't know what to do with it, so it doesn't absorb it. And what's the serving size of potato chips? The whole bag. And so people who were eating the whole bag of these potato chips with olein, and you didn't absorb any fat. What the hell? I don't know. Let's go to town. I was one of those individuals. And oh man, severe gut cramping. I thought I was dying. My poop was white. It was truly insane. And that's steatorrhea. So that's how you would know. The poop's going to go out really quick, really fantastic. So some other issues as well.